Okay, so again, yesterday we looked at how to find the derivative at a point, and we used a different equation. And there's a little bit of interchangeability between the equations, but I would recommend you use that one for derivative at a point, and then we'll use this one for the derivative of the function. So what this is going to give us is going to give us a new function. It's going to have variables in it. It's going to have an x in it, most likely, right? And that's going to show us, and we'll actually look at its graph later and see what that looks like and all kinds of stuff. And it can define a lot of different points. Maybe we'll compare something we did yesterday's answer to one that we'll look at this way. But the derivative of a function f with respect to the variable x is the function f prime. Now I could have called it dy over dx if I wanted to, same thing. Whose value at x is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h, provided the limit exists. If the limit doesn't exist, it's not differentiable there. So again, I like to kind of remember these things in terms of pictures. So what I did here is this is very similar to the picture we looked at yesterday, but we used the points, what, a and x or something. But today, just one point that we can look at is going to just be, oh, here, I guess I should have made these x's. Let's kind of do a different version of this. But again, it's just a random variable, so I apologize for that. This is x, f of x, x plus h, x plus h, x. Okay. So if we want to find the derivative of x, right, which is our generic input, right? So we know that this point would be x, f of x, right, would be its ordered pair, its xy pair, input, output. We want to look at some other point, we'll call it x plus h. I like to picture it being to the right, it could be to the left, it doesn't matter, right? H could be positive, h could be negative. But what we'll do then, it has the ordered pair of x plus h, f of x plus h. So again, we can think about the secant line between these 2 points, right? And then as we let h approach 0, this point would move towards x, correct? And then when we take the limit, it's the same point, right? So that's going to give us our tangent line. But if you look at this equation for the difference here, or if you think about the secant line, which I guess I can draw that on there, and you think about how we would find its slope, right, this purple secant line, but its slope would be f of x plus h minus f of x over x plus h minus x. Right, so just, change in y, change in x. Now, up top, because it's in a function, we can't cancel anything, right? You have to evaluate the function and do the work, and that's what we're going to look at today. But here on bottom, we do have x plus h minus x. So you can see that the x's are going to go away. So that's how we get this formula f of x plus h minus f of x over h. And that's what we have in here, and that's what we take the limit of. So personally, when I look at it, this helps me to kind of be comfortable with the idea that the denominator is just h, right? Because it is actually a slope formula, but it was x plus h minus x, right? But then it canceled out. That's why it's just h down here. It's not some sort of, magical math formula handed down from Newton that no one understands. It's just a slope formula. The x is canceled. That's all that's going on there. Okay, so for our first example here, again, we're going to find the derivative of just a general equation for the derivative, not just a number like we did yesterday. So with this, we're going to be using the limit of the difference quotient, right, is what we're looking at there. But what I would probably recommend doing, especially early on until we get a little more comfortable with it, is let's go ahead and find, we know what f of x is, right? It's written right there. We already have that. I would recommend maybe finding f of x plus h kind of off to the side, because that's usually where things can get a little weird. But we have 2 and then x plus h squared minus 7. Again, f of x plus h, we take the x out, we replace them both with x plus h. Now it's going to need to be expanded because we're going to have a bunch of stuff canceling. Is basically what happens on most of these. So we get 2x squared plus 2xh plus h squared minus 7. I just did the binomial square pattern, but if you don't know it, you need to write x plus h, and FOIL it, or make a tic-tac-toe, whatever you do. You got to be able to multiply the two binomials correctly. We'll distribute the 2. 2x squared plus 4xh plus 2h squared minus 7. Does that work? So there's nothing else we can do with that now. So now, to find f prime of x, that's the limit as h approaches 0. And we said it was f of x plus h minus f of x over h. Again, I would recommend you write the formula out a few times just to kind of get used to, just so you learn it. So now let's substitute and see what we get. So f prime of x, I'm still writing my limit. And again, this is really about showing how we're doing this process. We're going to have much easier ways to find derivatives moving forward here. So here, I'm going to take f of x plus h, and I'm going to replace, this is the expression for that. So that's why it was nice to find it off to the side. You get to write limit about 5 times less, right, than if you did it in the formula. So 2x squared plus 4xh plus 2h squared minus 7 minus, then f of x is 2x squared minus 7 over h. Now, the parentheses here around the 2x squared minus 7 are super important. If you forget those, it'll be wrong. Like, it just won't work. The parentheses around here, I just didn't want it to feel left out. Right? They don't really do anything. But this negative being distributed is usually why people miss these, is they fail to distribute the negative. So let's look at what's going to happen, though. When you distribute this, you get a negative 2x squared, correct? And there's also a positive 2x squared. So they're going to cancel. Okay, if you look, here's a negative 7. When you distribute this negative, this becomes a positive 7. So those cancel, which is really what we needed to have happen there. Okay, so with this now, we get the limit as h approaches 0. We have 4xh plus 2h squared over h. We need to get the h on bottom to go away, because still if you try direct substitution, it doesn't work. Right? You get it indeterminate, but got an option. Here, I would recommend only factoring an h out of the numerator. You could take a 2 out, it's fine, but we really just need to get rid of this 1 on bottom. So the answer is going to look a little better if we just factor a single h out of the numerator, like that. Now these h's will cancel. So that's the limit as h approaches 0. Those cancel. We get 4x plus 2h. Can we evaluate the limit? Sure. So the h becomes 0. So 2 times 0 is just 0. And 4x remains 4x. So f prime of x is 4x. Right? So we'd say the first derivative of 2x squared minus 7 is 4x. Now, if you say you wanted to find what the derivative, or what's the slope, so you can, even with this now, say we're asked what's the slope of the tangent to f of x equals 2x squared minus 7 at x equals 3. Right? So this was the type of question we answered yesterday, correct? So if that's the case, well, we don't need to go through all the work that we did yesterday now that we have this derivative function, because we know that f prime of x equals 4x. So then f prime of 3 would equal 4 times 3, which is 12. So the slope of the tangent line at 3 would be 12, because we could just plug 3 into our derivative function. Okay. Or the slope of the tangent line at 0 would be f prime of 0, which would be 0. at -1. F prime of -1 would be -4. Does that make sense there with that? And then could you write the, if you wanted to maybe write the equation of this tangent line? Well, let's see. For this point, if we put 3 in here, we get 18 minus 7, which is 11. Right? So we know the point, we know the slope. So y minus 11 equals 12, x minus 3. So we could do the same idea there. We're doing the same stuff. It's kind of a different way there. Instead of finding just a number for the derivative, we're finding an equation for the derivative that we could plug our input back into to find the slope of the tangent line. Okay, I had a great question here. Kind of what are we doing with this thing? Well, okay, great, 4x. Why do we care? Let's look at what we can do with this. So this again, this was the answer to the problem we just did. So suppose this is our graph of 2x squared minus 7. It looks something like this. Graphs always look a lot better if you don't put scale on the axes because then they're probably right, unless. Okay. But say we want to find the equation of the tangent line at x equals -2. And we know the function and we know the derivative. Okay, now, to find the equation of the tangent line, we know we're going to do y minus y1 equals m x minus x1. So we need 3 things. We need the x value and the y value of the point, and then we need the slope. Okay, so to find the point, we do f of -2. So we plug -2 into this equation. So we get that. That gives us, 8 minus 7, which is 1. Right, so that gives us our point is going to be -2, 1. Okay. And then the slope, we're going to do f prime of -2. So that's going to show us the slope of the tangent line at that point. So then we'll do 4 times -2, and that gives us -8. So that means that this is going to be our x sub 1, that's going to be our y sub 1, and that's going to be our slope of that tangent line. So that means we would get y minus 1 equals -8 x plus 2. That's how we do that. So the advantage to this technique is, the other day we just found one single slope at one particular point, and you go through that whole process. But now what if I wanted to find the equation of the tangent line at x equals 5? Well, I would use the same 2 functions, right? I'd put 5 in here to find the point, I'd put 5 in here to find the slope, then I could build a tangent line equation really quickly. That's what we're doing here. Now, there's a lot of other things we'll do with the derivative function. I mean, one of the first things is like if this was a position time graph, this would be a velocity time graph. So, or if this is your profit function for your lemonade stand, right, this would be your marginal profit function for your lemonade stand. How much money you'd make on the next cup of lemonade is kind of what it's saying. And it's also, again, the instantaneous slope at that point, right? So that's why we do that. Okay, so from our handout here, we have this example here, number 2. And the function is f of x is 1 over 5 minus x. Now we know that we're going to plug that into to find f prime of x. It's going to be the limit as h approaches 0 of f of x plus h minus f of x over h. So we know the formula. Probably not a bad idea to maybe figure out what that looks like ahead of time. So over here, let's see, f of x plus h is 1 over 5 minus x plus h. And then here that negative will be distributed. Very important to note that. So f of x plus h equals 1 over 5 minus x minus h. So if I go ahead and plug into here, again, limit as h approaches 0 of 1 over 5 minus x minus h minus 1 over 5 minus x all over h. Does that look okay so far? Now, we need to subtract these, we need a common denominator. which is just this thing times this thing. I'm sure none of you would do this, but you can never just like subtract an h from top and bottom. That would just be silly, right? That's not legal. So, but again, if you had 1/2 and 1/3, you know that you multiply 2 and 3, the common denominator would be 6. Here we get this mess and this mess. You multiply them together, you get a common denominator. So to do that, what that looks like is we have 1 times 5 minus x over 5 minus x minus h times 5 minus x. So I just took this one, multiplied by 5 minus x on top and bottom. And that's what I had on the right-hand side. I'm going to multiply by 5 minus h minus x minus h, 5 minus x minus h, and it's all over h. So again, I'm just getting a common denominator, correct? It looks pretty bizarre, but let's go ahead then, now that these have a common denominator, let's go ahead and put them together to get a single fraction in the numerator. So we get 1 times 5 minus x minus 1 times 5 minus x minus h over 5 minus x minus h, 5 minus x. Now at this point, I have a single fraction on top. Yep. I get really tired of making this giant fraction bar. So what I like to do, once I have a single fraction, a lot of times I just write times 1 over h. Right? Because if it's a single fraction, it's good. Like I probably wouldn't do it before then, but a lot of times at that point. Does it work for everybody, how we can do that? Instead of dividing by h, we multiply by its reciprocal. It's still not going to do anything for a while. It's just going to sit there. Now at this point, we're going to simplify, but don't mess with the denominator. Leave it the same. It's already factored. It's fine. This one's not, though. It's got a minus 1 out here that has to be distributed. So that gives us then the limit is h approaches 0 of 5 minus x minus 5 plus x plus h over 5 minus x minus h, 5 minus x times. Now, could I even just put the h on bottom here? Because it was times 1 over h? Yeah, let's do that. So let's put that h on bottom. We know that we have to get rid of that because that's where our limit's going to, have a problem doing that. So if we look at the numerator, well, we have a 5 and a negative 5. Those cancel. We have an x and a negative x. Those cancel. And then we have this h. Yeah? So then from here, okay. So then we will get the limit as h approaches 0 of h over 5 minus x minus h, 5 minus x times h. Well, guess what cancels? The h's cancel. Now, once they do that, we should be, well, I feel like I might have missed a negative sign somewhere, but let's find out. So limit as h approaches 0 of 1 over 5 minus x minus h times 5 minus x. So what's going to happen here when we go ahead and do the limit? That's the only, yeah.
The answer at the bottom of the page is 1 over 5 minus x squared.
That's okay. So I did it right. I was afraid I missed a negative somewhere. This is good. But look, what's this h become? 0. So once we do substitution, you get 1 over 5 minus x times 5 minus x, which is 1 over 5 minus x squared, which would be f prime of x. So that would be our derivative function there. Oh, I never mind. I dealt with the negative in my head. I know what happened to it. It's beyond the scope of what we know, but I was just kind of looking ahead, right? But that's the process there.